Recording. Boom. Okay. So, hi, I'm Janine Nakakura. I am a resource teacher with the Hawaii State Department of Education in the Office of Curriculum and Instructional Design, otherwise known as OSID. And we'd like to welcome you here to our learning event today, where hopefully you'll learn something that you can take back with you to your school or office. And then I'll let Faith introduce herself.
Hi, Faith Ishihara, same office, digital design team, computer science. And we're really happy that you're able to join us. We're looking forward to having some fun today.
And I'll put the agenda link into the chat again. Also, if you read our beginning slide, if you can tell us who you are or what your role is at your office or school and what brings you here today. And today we're going to cover just a brief overview of computer science and who is Ada Lovelace. And hopefully we'll give you a little taste of computer science, and in the future learning events, you'll learn a little bit more about each of the 5 core concepts. Okay, so next slide. So that's us. Okay, and here's the agenda. So I put the agenda link into the chat. So if you click on that link, it will take you to our presentation slides, any other resources we mentioned during this presentation, and it will also give you an idea of our 30 minutes. Okay, so what are we going to do in these 30 minutes? So one of the things that I want to start with is a bell ringer activity. And we're not going to do the whole activity, but this is something that you might want to do with maybe people you know at a meeting, teachers or admin or students. Here's some terms, and I'd like you to think about where they would go into the 5 core concepts of computer science. And you're thinking, I don't know what the 5 core concepts are. Well, we hope that by the end of the school year, after all of our learning events, you will have a better idea of where these vocabulary words go. For example, big data. Okay, I did that one for you because it was easy. Big data, data and analysis. And then a lot of people think computer science, coding. Okay, where does coding go? Under algorithms and programming. So there are some other words listed below, and think about where they might go in the 5 core concepts. And if you don't know what they are, we have a little video to show you. And by the end of the year, I think you'll be more familiar with all of these terms and perhaps where they might go. And they might overlap in some areas also. Okay, next slide.
Okay,
I'll
thanks,
turn it
Janine.
over to Faith.
Yeah, thank you. So as Janine mentioned, I mean, when people think of computer science, they typically think writing code or programming, but it really is these 5 core concepts that Janine shared in our bell ringer activity. So we wanted to share with you what those concepts are, and through this video. So we're going to share that with you and listen to the video and see if you can learn something that you didn't know before.
What do you think about when you hear the words computer science? Computers, coding, programming? It's this and much more. Let's go back to the drawing board and look at the K-12 Computer Science Framework. This framework organizes computer science into 5 core concepts representing key content areas. The first core concept is computing systems, which includes devices, hardware and software, and troubleshooting. People interact with a wide variety of computing devices that collect, store, analyze, and act upon information. A computing system is made up of hardware and software and communicates and processes information in a digital form. An understanding of hardware and software is useful when troubleshooting a computing system that does not work as intended. The second core concept, networks and the internet, deals with network communication and cybersecurity. Computing devices typically do not operate in isolation. Networks connect computing devices to share information and resources. Cybersecurity deals with transmitting information securely across networks. The third core concept, Data and analysis involves storage, collection, visualization and transformation, and inference in models. Computing systems exist to process data effectively. Data is collected and stored so that it can be analyzed to better understand the world. The fourth core concept, algorithms and programming, includes algorithms, variables, control, modularity, and program development. An algorithm is a sequence of steps designed to accomplish a specific task. Algorithms are translated into programs or code to provide instructions for computing devices. And the last core concept is impacts of computing, which includes culture, social interactions, and safety, law, and ethics. Practicing good digital citizenship empowers our students to make safe, smart, and ethical decisions. So the next time you hear computer science, remember the 5 core concepts from the K-12 Computer Science Framework. Let's teach our students to be computationally literate and proficient in the concepts of computer science for the 21st century and beyond.
Okay, so hopefully that helped you get a better understanding of the 5 core concepts. And each month at our learning events, we're going to go a little bit deeper into each one of those concepts. But today, being our first event, we're kind of going to give you an overview. Let's see. Now that we have that, now that we've seen the video, hopefully, we know what we want our students to be aware of as well. We want them to be familiar with the 5 core concepts, and so that they can be better prepared for the digital world we all live in. And on this slide, we've also included a few links that we hope will be helpful to you. So the Computer Science Teachers Association has computer science standards for students that are filterable. And we adopted this, Hawaii DOE adopted these standards in 2018. We also included the link for the K-12 progression chart that will show you by grade bands as the concepts progress through the grade levels, and computer science teacher standards. And as we learn about computer science, you may hear the name Ada Lovelace. And who was she, and why is she known as the first computer programmer? So we're going to share some information from these 2 books, Ada Lovelace, The First Computer Programmer by Amy Hayes, and Who Says Women Can't Be Computer Programmers? The Story of Ada Lovelace by Tanya Lee Stone. So Ada was born Augusta Ada Gordon. She's the daughter of George Gordon Byron, commonly referred to as Lord Byron. Her father, Lord Byron, was one of the world's first celebrities. He was brilliant, emotional, and wrote beautiful poems that are still read today. Her mother, Anne Isabel, was strict, religious, and very focused on academics. Lady Byron wanted to make sure that Ada would be ruled by logic and not emotion. So she took Ada and separated from Lord Byron when Ada was 1 month old. Lady Byron disapproved when Ada played imagination games. She decided she would fill Ada's head with math. And so by the time Ada was 5, she was learning the basics of geometry. She could add together sums of 5 or 6 different numbers. And Ada's mother would hire the best tutors that she could find for her daughter. When Ada was 17, she came out to society. She met many interesting people. One person, Charles Babbage, was working on a machine that performed like a calculator. And Ada took such interest in this machine. She was really fascinated. She examined the gears, the rods, the wheels, until she figured out how it worked. And in 1834, Babbage shifted his focus to a new machine called the analytic engine that went beyond calculating numbers and functioned based on instruction. Babbage had seen jacquard weaving looms that used cards with specially placed holes. Each card told the loom which color thread or design to weave, and the looms could weave complicated patterns that looked like paintings. Ada understood how the machine works. She understood mathematics, and together with her imagination, the analytic engine could adapt to the punch card system to follow algorithms of unlimited instruction that today we call computer software. And for that reason, Ada is known as the first computer programmer. In 1835, Ada married William King, who became the Earl of Lovelace. She became Augusta Ada King, Countess of Lovelace, or Lady Lovelace. So the name Ada Lovelace is not really accurate, but that's the name that has stuck over time. Sadly, Ada Lovelace passed away shortly before her 37th birthday, but her discoveries and work have lasted over lifetimes. So to access these books, you can, from our statewide ebook collection, you can visit soraapp.com. And if it's your first visit, you're going to click on a green button that says My School is Hawaii State Department of Education and enter your 8-digit employee number. And for students to access this statewide collection, they would enter their 10-digit student ID number. So in addition to the large library that is the statewide ebook collection, the computer science team has curated a computer science bookshelf that resides on our internal CS support site at bit.ly/HIDOE-CS. And there are currently about 100 computer science related titles there. So here's a punch card activity. On the left are the ASCII binary alphabets. And on the right are the same ASCII alphabets in punch cards, converted to punch cards. So, and I'll mention that if you're checking them out, the ASCII list has only 7 digits and the punch cards have 8 digits. So if you put a 0 in front of each alphabet on the ASCII list, then you'll see the exact correspondence of the pattern. So this activity is a nice way to introduce students to binary numbers and computers. But today, let's decode these 5 letters. So what do they spell? And type your answer in the chat. I'm going to ask Janine to kind of monitor the chat because I can't really see it.
Oh, we have a couple of people, 3 people with answers, 4 people, and they all say Byron, Thaddeus, Cheryl, who's Mike, I think, and then Celeste, Nicole, Anna.
Oh, awesome. Thanks for participating. Okay, so
Now they can program. They can be hired as a programmer.
Yeah. So I'll let Janine talk about this next part. You know, how we're gonna figure out who's gonna get prizes.
All right. So we have prizes here, and we already get this morning in our morning session we gave away the earbuds. So we have 3 prizes left: the water bottle, the pen and notebook, and the Notable Women in Computing cards. So if your name, first name, is closest to Byron, then you will be the winner of a random door prize. I'll mail it to you via armored car. So look at the list of names in our participants and see whose name, first name, is closest to Byron. And if you think your name is closest to Byron, then type your name in the chat. And if this morning Charles, our administrator, was the one who was giving away the prizes, and he said if you were wrong, then you owe us a prize. But I won't do that. Just if you think your name is closest to Byron alphabetically, your first name, then type your name in the chat. And yeah, if you're the winner, we will send you a prize via armored car. And it doesn't matter what the amount of letters. It's just whose name is closest alphabetically. Like if we were going to make a list of names in alphabetical order, whose name would be closest to Byron? And this is you know, it's kind of, you know, like logical thinking. Maybe you're using an algorithm to match, you know, the names or figure out which name goes first, second, third. Grant. Everybody knows Grant. Why is everybody like mentioning Grant? Grant, are you so famous and popular?
He is famous and popular for sure.
Well, I can see two possibilities. You know, whose names are closest to Byron. We're going with Byron. Okay. So first names, whose names are closest to Byron? I see 2 people. And which one of the 2 is closest? Nicole says Anna. Okay, so Nicole, why do you say Anna? Anna, or Celeste says Cheryl, who I think is Mike. Anna or Celeste. Okay, which one is it, Anna or Celeste? How would you determine which one is closest alphabetically to Byron? And John thinks, so why do you think Celeste, John? Anna, Byron, and Nicole made a list.
Because the Y is at the end of the alphabet and the E. So I think the Y pulls it too far away from the N in Anna.
And then Thaddeus is saying Anna closer to Ada. Okay, but we're going with but that is correct. You're right. I like the divergent thinking going on. Okay, so
I'm thinking Anna because the N is closer to the Y versus the E. So if you go right, so ABC, it doesn't matter because they're all, one is on each side.
Uh-huh.
Then if you look at Y, right, for the Byron, there's N and then there's E. So I'm thinking the N is closer to the Y.
How close is the
Y.
N to the Y? How close is the N to the Y?
Let's see. Wait, 1, 2, 3, 4.
12 letters?
11
letters?
versus,
Well, by that logic, it wouldn't matter because the E is before the N.
I love the discussion and thinking going on. So Nicole, you said how many letters away is N from Y?
11.
And how many letters away is Y from the second letter in Celeste, which is E?
20.
20. Oh, okay. So which way are you going? Are you going forward or backward?
I'm going forward.
Okay. Does anybody else want to give an explanation? Anna says 6 away. Why do you say 6 away, Anna? And you can speak up too if you want to turn on your
Because
microphone.
if we are doing like, you know, a looping code than Y, Z, A, B, C, D, E.
Uh-huh.
Loops. So I'm just thinking that it would, there's no end. It's infinity. So once you end, you begin again. That's what I think of for binary.
Wow. You know what? There is no one correct, and I think both explanations could be correct depending on how you look at the problem and the parameters. So I will write down Anna and Celeste as winners, and I will mail them something. Anna is in our office, so I'll just drop it off on her desk. But
I'll be there Friday.
I'll be there Monday. So yeah. So congratulations to Anna and Celeste. I was thinking it was Celeste, but when Nicole explained about how, which way she went in the alphabet, then I was like, oh, that might work. And then Anna had a whole different explanation about loops and binary, and like, okay, well, I think we should just give two prizes.
Wow.
So thank you. Thank you for playing the game. And I think we're gonna have door prizes at every learning event. People seem to like it.
Thank you so much. That's awesome. Okay, so we'll take a look at the next slide. And we wanted to let you know that there are recent legislative updates related to computer science. So we put together this short video that shows where we have gone, Hawaii DOE, from the beginnings of computer science and what lies ahead of us in the coming 3 years. So let's watch this video.
Computer science provides a platform for fun, relevant, and engaging learning. As a state, we have taken several steps to infuse computer science into all K-12 schools statewide. Let's take a look at where we started and where we are headed with computer science in Hawaii. In 2017, the Hawaii State Department of Education formed a computer science work group to convene a community of internal and external partners to explore how pre-K through 12 students can have computer science learning opportunities in school and beyond. The work group incorporated feedback from educators and stakeholders into a state action plan for computer science education to ensure that computer science learning and opportunities were provided with equity and access for all students. On May 3rd, 2018, the Hawaii State Board of Education approved the adoption of computer science standards based on the K-12 computer science framework. On June 21st, 2018, Governor David Ige signed into law Act 51 to develop and implement a statewide computer science curricula plan and ensure each public high school offers at least one computer science course by school year 2021 to 2022. On November 14th, 2019, a Department of Education memo shared system updates that would take effect during school year 2020 to 2021. Equivalencies were identified to allow teachers to be Hawaii qualified in computer science. Computer science replaced the educational technology category in Infinite Campus. In addition, computer science was added as a content option for the additional content area section of the elementary report card. Advanced placement computer science courses categorized under multidisciplinary were changed to computer science. On July 1st, 2021, Act 158 was signed into law by Governor Ige and requires the Department of Education to address the following. 1. Beginning with the 2022 to 2023 school year, at least one public elementary and middle intermediate school in each complex area shall offer computer science courses or content. 2. Beginning with the 2023 to 2024 school year, no less than 50% of the public elementary and middle intermediate schools in each complex area shall offer computer science courses or content. And 3. Beginning with the 2024 to 2025 school year, all public elementary and middle intermediate schools shall offer computer science courses or content. By June 30th, 2022, and each June 30th thereafter, the superintendent shall submit to the Board of Education and Legislature a report of the computer science courses and content offered during the previous school year in each complex area. As we look back at the accomplishments that have been made, we are encouraged in continuing our journey to provide all students with equitable and accessible computer science opportunities.
So as the video mentioned, it's about equity and access. So we have some exciting times ahead of us, looking in 3 years where all students will have opportunities, learning opportunities for computer science at their schools. Thanks so much for joining us. We have a feedback form and we'd love to hear your thoughts about these learning events and of course how we can make them better. And we have a few minutes if you could fill it out before you leave today. And at the same time, we'll open it up for questions. We hope by joining today, you have a better idea of what computer science is, where to locate the standards, the progression charts, how to access the ebook statewide library. And we hope you had fun. So it's go ahead and ask us any questions and please fill out the feedback form. And you can unmute yourself if you have questions.
And I put the feedback link into the chat. If you could, oh wait.
Sorry, what did I
Did I
do?
put it in there? I thought I did. Sorry.
What's in there?
Feedback link. Wait, let me do it again. I thought I put it in there, but I
You
don't
did?
see it. I've got two computers going, so here's the feedback link.
Did I mess up?
There, here we go. Here we go. Feedback. Feedback form. I know you're really busy, so if you could do it before you leave, it should take 2 minutes.
I'm gonna stop sharing so I can see the chat.
Feedback form link. And thank you for joining us today. We know everyone's super duper busy, and we hope to just make this, just make this really something that you can learn from in a short period of time and make it interactive so we're not just giving information and talking the whole time. So thank you for your participation, and we hope to see you at a future event. And please feel free to reach out to us, Faith or Janine, if you have, a question that's more detailed, or you need some resources, or just anything related to computer science, please contact us. The recording, I have the morning recording, and this one should be processed in a few minutes, I'm thinking, and then I'll listen to it just to make sure nobody said any bad words, and just joking. But I'll listen to it, and then I'm thinking I'll post at least one, but if both are good, then I'll post both, but at least one of them will be posted like in an hour or two. And if you just joined us, I will put the agenda link in the chat. All of our links are there. So you can just go there and get all of the links, the slides, everything. And I'll put the recording link into the flyer. So the flyer for this event I will try to put everything in there so that you don't have to go to different sources. And I also put in the 808 Educate calendar. Okay, so here's copy, paste the flyer. Here's the flyer. And we want to thank John for attending both sessions today. Yes. And we thank Celeste for putting in the HSTE newsletter. And we thank Shane for showing up early yesterday and volunteering to present at a future learning event.
Yes, so stay tuned. Good to hear from Shane.
Yes.
And anyone
We got me busy.
wants to share.
What did he say? Sorry.
No, I'm taking Shane's class.
Oh, Shane, everybody knows you.
Yeah.
All right, so that's the official end of our session. But if you want to hang around and just talk story, feel free to. We'll hang around for a few more minutes. And we really appreciate the great discussion today. Like, is Anna's name or Celeste's name closer to Byron alphabetically? That was a great
awesome. So we'll stop the recording and hang out a bit.
Thank you for reminding me. Keep forgetting. Stop the recording. Okay, there we go.